So we've covered the vertical shifts and the amplitude and period changes. So really the last thing to talk about is the horizontal shifts. So you probably remember when you have one of these inside changes like this, right? X minus b on the inside, that was actually a horizontal shift either to the right if b was a positive number or to the left if b was a negative number, right? But remember, the idea is that negative sign, that minus sign is always there. So if you see, a minus sign there, it means it's going to the right. If you see a plus sign there, it means it was going to the left. So that's why you had to be a little bit careful with these horizontal shifts. So there's your summary box there, talking about the amplitude, period, and horizontal shift. Remember, so the number out front, the A value, the absolute value of that was your amplitude. That K value, that would be used to find the period by doing 2 pi divided by that value. And then that B value there is going to be the horizontal shift. So here's an example. Find the amplitude, period, and horizontal shift of this function, y equals 3 sine of the quantity 2 times the quantity x minus pi over 4, and graph one complete period. So how would we get the amplitude? All right, so the amplitude comes right from this. So the amplitude is going to be the absolute value of 3, which is 3. The period is going to come from this. So the period is going to be 2 pi over that value over 2, which is pi. And the horizontal shift is going to be this value, and there is a minus sign there. So it's going to be pi over 4 to the right. Right? I can write, if I wrote negative pi over 4, it'd be assuming that it was shifting left, but I'll just make it clear though. So since it's positive, that means I'm shifting to the right. So there's my amplitude, period, and horizontal shift. So now what am I going to do? Well, I know this is the sine curve, okay? And I know it was shifted pi over 4 to the right. So my main cycle, right? My main cycle that I'm going to go through is going to start at pi over 4, right? So it starts at pi over 4 and ends pi units later. So one complete period is going to occur in the interval between pi over 4 and then pi over 4 plus the period, which is pi. And then if I simplify this, it means one period is going to occur between pi over 4 and pi over 4 plus pi, which is 4 pi over 4, is going to be 5 pi over 4. So what you would do is you would put your starting point at pi over 4 at 0, because that's where the sine curve normally starts. It would end again back at 0 at 5 pi over 4. And now, since the amplitude was 3, it's going to go up to a maximum of 3 and a minimum of negative 3. And then what you want to do really is to find what these other x values are, is you're going to break it up into quarters, right? So since you started at pi over 4 and the period is pi, right? So you break the period into quarters. So each point, right, that we're going to call quarter points are going to lie pi over 4 past pi over 4. So we're going to have a point at pi over 4 plus pi over 4, which is going to be pi over 2. Then we're going to have another point at pi over 4 plus 2 pi over 4, which is going to be 3 pi over 4. Then we're going to have another quarter point at pi over 4 plus 3 pi over 4, which is going to be pi. And then by the time we add 4 pi over 4, which is the period pi, to pi over 4, we get back to where we started, and that's 5 pi over 4 again, right? So at pi over 2, it hits a maximum of 3. Then at 3 pi over 4, it's back down to 0. At pi, it hits the minimum of negative 3. And then at 5 pi over 4, the cycle is complete. So there's your one complete cycle. So what I normally do here is I normally think of pi over 4 as being like the new y-axis here. Instead of having it at 0, I think of it as being like the new y-axis, and I just draw a period there. And I wouldn't even worry about trying to graph, more to the right and to the left of this. I mean, if you can, nice, but you don't have to. You just want to get one main period in there from pi over 4 to 5 pi over 4. All right. So now in this case, we have a cosine curve. So the first thing you want to do with this one is you notice that it's not in our normal form. We actually have this. So what we want to do is we want to factor out that 2 so we can better see what the horizontal shift is going to be. So we're going to write 2x plus 2 pi over 3 as 2 times the quantity x plus pi over 3, right? And then you can see if you distributed that, you would get 2x plus 2 pi over 3, which is what you want. So I want to write our function actually in this form. So I'm going to write it as y equals 3/4 times the cosine of 2, and then parentheses x plus pi over 3. So now I can clearly identify what my amplitude, what my period is going to be, and what my horizontal shift is going to be, right? So my amplitude is going to be the absolute value of 3/4, which is 3/4. My period is going to be 2 pi over 2 again, which is again pi. And my horizontal shift is going to be negative pi over 3, which means left pi over 3 units. Right? Again, I put the left in parentheses just to make it clear that that's what that negative sign means, right? That I'm shifting left. So my amplitude is 3/4, my period is pi, and my horizontal shift is negative pi over 3. So that means I'm going to start my cycle, right? I'm going to start my cycle at negative pi over 3. And then it's going to end at negative pi over 3 plus pi, which is actually going to be 2 pi over 3. So the interval that I'm looking at is actually going to be from negative pi over 3 to 2 pi over 3. And then we can also find the quarter points then, right? By realizing that we're going to start at negative pi over 3, end at 2 pi over 3, and this thing is broken up into pi over 4, right? Into sections of pi over 4 because the period is pi. So each quarter point is going to be at pi over 4 beyond negative pi over 3. So we're going to have, that's a trickier one to do. So we'll just wait for the graph to that because that's going to be tough addition and subtraction. So we'll look and we see that the cosine curve, right? It started here at negative pi over 3 and it ended here at 2 pi over 3. The difference here was that the amplitude was 3/4, so it started out at a maximum value of 3/4 and it went down to a minimum value of negative 3/4 halfway, and then of course it ended up again back at the maximum value of 3/4. Now how did they get these different quarter point values? They got them by starting at negative pi over 3, right? And you break up the entire period pi into quarters, right? So pi over 4, the period is pi, so you break it up into pi over 4. And how do you get negative pi over 12? Well, negative pi over 12 is actually negative pi over 3 plus pi over 4. That's going to equal negative pi over 12. And that's where it gets down to 0. All right? And then from negative pi over 12, if you go another pi over 4 to the right, that's going to bring you to 2 pi over 12, which is pi over 6. And that's where it hit your minimum value. And then how'd you get the 5 pi over 12? Well, you did pi over 6 plus pi over 4 again, and that's going to give you 5 pi over 12. So that's how you knew what these other x values were, right? So what I usually will do is I'll just put one regular cosine curve in, right? Knowing that it starts at 3/4 when x is negative pi over 3, ends at 3/4 when x is 2 pi over 3, and then I just use this process to figure out what these other 3 x values were, and then I just place them in accordingly, right? And again, these are called your quarter points. So there's really 3 additional points that you'll always need to find, right? You'll know what your starting point is and your ending point, and then you'll need to find those 3 other quarter points that lie between that starting and ending point.